This is the definition of the transpose of a tensor. The transpose, A transpose of a second order tensor A, is defined for all vectors A and B by this identity. Now, we want to use this identity to show these relationships highlighted in green. To do that, I'll start with the first one, C, 1D transpose, and I want to apply the definition. So what I'll do is I'll apply that to some vector A dotted with some vector B, and by the definition this should be equal to C bond D transpose again, and the transpose of a transpose is the vector itself, is the tensor itself. So C bond D applied to B dotted with A. Now that's equal to D dot B along C, and the dot A remains, so that's D dot B C dot A. Very well. Now I'll take the B dot outside as a common factor, and I'm left with C dot A dotted with or along D. And I can do that because the dot product C dot A is just a scalar. Now this term in the brackets I can now rewrite as a tensor product. So I'll get SC, actually a D bond C applied on A with the whole result dotted with B. Okay, very well. So now comparing our initial result, our initial proposition and our final result, since this is true for all vectors or any vectors B and A, then we have that C 1 D transpose is equal to D 1 C. So here we use the fact that the transpose of a transpose is the vector, is the tensor itself, which we can show. Okay. Now let's do the second proof. I want to show that A 1B plus C 1D transpose is equal to this. So I'll do the same thing transpose, and I'll apply that to some vector E dot the result with F to get to get the tensor transposed. Okay, acting on F dotted with E, which is equal to B dot F A dot E plus D dot F C dot E. Okay, taking the dot F as a common factor, I think taking the dot E as a common factor, taking the dot F as a common factor, I'll get A dot E along B plus C dot E along D, which gives us F dotted with B bond A plus the bun C acting on E, I can use parentheses here and brackets for the whole thing. And again, since F and E are any two vectors, then this is equal to this.